Okay, so any questions in the previous classes? This is where we were. This was the pseudocode of range min problem, where each query will be what is the minimum in a given 1D array between I to j. So we did this by storing for every I storing few j values, only log many j's, basically interval sizes power of 2. And then when a query arrives, we just look at 2 entries in the matrix and give the answer. So how that matrix B is constructed, that also we optimized. So we got this theorem that the matrix B, which is kind of your data structure, that can be built in n log n space. This is a fun time investment, and after this, any query can be solved in constant time. And the space is also the same, n log n. Is that clear? Any questions? So this pseudocode you can write and you can try to even implement. So we look at more standard data structures. We'll start with that. So data structure design involves 2 broad steps. So these will be now DS which are other than arrays and matrices, okay, more involved things. For different problems, we'll have to design different types of data structures. So first will be, first step when you see a problem, it will be what is the data structure model. So that is the mathematical modeling that we have to do. So in this model part, you just have to define what the DS will be and then how it will be updated and queried. Okay, you have to give the, I shouldn't say how it will be queried, but what are the list of operations. So what is the DS and what is the list of operations that your DS should be able to provide. So that is the modeling part. And second part is once the this is the problem statement or the design statement, the design requirements. Second will be to meet these requirements by an efficient implementation. So second part will be implementation. So this implementation ultimately will be very partly in the RAM and most of it in the hard disk, right? So you have to give basically the pseudocode or the program, implement the program, keeping the model in mind. So let us just describe that. So step 1 is about giving the abstract description of the data format and the operations. So operations will be usually in two categories. One will be what kind of queries and other will be what kind of updates. So query is basically reading the DS, and update is also allowed to edit or write. In query, you are not allowed to write. The data structure cannot be changed. So these come with different permissions. So the output of this step 1, will be called EDT, which is the abstract data type. Okay, so the EDT is basically just a type that you have defined. Okay, so it will not be as simple as int or an array of int. It won't even be as simple as a matrix of integers, but it will be usually more complicated because what are the operations which are defined on the type int? When the computer stores, for example, int x, what can you do with x? Well, you can read the value of x, you can print it, and you can update it, right? You only have two operations. But in these more general ADTs, there will be 10, 20 operations, okay? Because it will not be just one variable, one int, but it could be, for example, data of all the citizens and everything. So you will have to have a long list of operations. So how this is done or how this is proposed, that's the definition. That output is called EDT of this process. Second step is just to implement it. But the implementation has to be very, very efficient. So this is about implementing the ADT. In a computer. So via a program, which in this course you can use C or C++. So you implement all these operations which you are promising in the ADT. So the output of this part is, or this step is, a program, let's say C program, for pre-processing. Like we did before, we created the matrix B, and query and update. Operations. Okay, so the distinction was not very clear in the previous example, because in the range main example, when we defined the mathematical model, when we gave the model, we actually also gave the program. So the two things were just one, because it was a matrix. So matrix can only be implemented usually you will just use the simplest way to implement the matrix, which is just say int b bracket bracket, right? So there is no real implementation options or choices that you have to make. So to impress on this distinction, we will now do a different example, which is list. Okay, so first we will do the modeling, the list abstract data type. And then we will see that there will be many implementation options, and some of them will be bad, only one will be good. So what is a list? Have you implemented a list in your programming course, for example? Yeah, linked list is more advanced, but even an array is a list. So you'd surely have implemented list ADT. But yeah, so we will also see, after array, we will see linked list. So examples in real life are, for example, roll numbers of students. Passing this course. Right, so not all of you will pass the course. So there will be a list of students who are registered, and there will be a list of sub-list of students who pass the course. Right, so these are already operations. So you have to first register the students, then you have to screen the students, and then you have to pass the students. So you have to do all these operations, and the list will keep changing. Right, so suppose in the output I just want roll numbers of students who are passing. So that is some work, right? It's a work lasting for 4 months. Or rooms reserved in a hotel. Now this has a lot of operations involved, because there are all these types of rooms and rates which depend on time and day, and it has to be done in years in advance, months in advance, right? And there are many requests and many changes. So this ADT you have to properly model and then implement, and so on, like students getting awards in the convocation. So these are very different examples of real problems, and the operations also are completely different based on the context. But one thing, I mean, with respect to computers, there is only one thing in common, which is that it is a list of either names or numbers. Right? So you want to store that list. So that is the thing which is common. So that all of these, they basically, when you store it, the syntax or the semantics, more importantly, which is common, is that it's a list of things. So let's just say that for now. So a list L, which is denoted by, elements are denoted by AI, goes up to, let's say, AN. So AI will be the ith element in the list. So this element can be a roll number, name of a student, name of a room, and so on. So in a list, is the order important? Yeah, so as soon as I have written 1 to n, it's already ordered. Right? There is no question about that. It's not that first element can be A1 or A2 or A3. First element will be only be A1. Right? So it's ordered. First will be A1, second will be A2. Now whether it has any meaning or not, that we are not claiming. So it may be meaningless. Saying that A1 is the first element and A2 is the second element may not mean that it's sorted. Roll number may not be sorted. So point is that it is not a set of elements, but it's a list of elements which is a ordered set. Right? It's not an unordered set. But it doesn't mean that it is sorted by any key. So which is why we have invented a new word, list, because we cannot call it a set, we cannot call it an array, we cannot call it a list of sorted integers and so on, right? So we have to invent something new, so we are calling it list. And so the important thing here is what are the operations that one wants from this data format. So what we want is the following. So what are the query operations on the list? So this is also part of the modeling. What kind of queries do you want once this L is stored on the machine or on the hard disk? So first is just to check whether it is empty. So is it empty? Right. So when this function is called, I mean, we are not talking about how this function is implemented. That is left to you and your programming. But the modeling just says that I want the existence of this function, which when called on the list, on an instance of the list, tells me the output will be yes or no. So yes if and only if the list has no element, it's empty. And obviously more interesting is searching for something. So search X in L. So this will output the answer to the question whether X is in L. So it says yes if and only if X is in the list, right? Again, at this step, we are not asking about a programming implementation. This is just a demand or a requirement of this ADT. So there is a long list of operations on a list. So let me just give all of them. So successor of location P in the list L. So this returns the element that appears after location P in list L. And similarly, the opposite of this is predecessor. So same thing, but before. Okay, so returns the element, or you have to return the element that appears before the location P in the list. So example, what is the successor of I in list L? Right. So in the list L, the ith element was AI. So successor will be AI plus 1. And predecessor will be AI minus 1. Okay, so this is the meaning of these two query operations. So note that all of these are, we are calling them query because you are only given read permission on the list. You are not given write permission. So you are not allowed, for these operations, you don't need to change the list at all. Right? So list is created by somebody who has the permission, and you can read and just output the answer.
Successor and predecessor, they will be kept for outer bound.
Yes, that's a good point. So in that case, you can output end of file. Okay, so if there is no successor, there is no predecessor, then you can say end of file, which means that you are at the boundary. So that also is a useful information, that you have reached the end of the list or you are at the beginning of the list, or the list can be empty, in which case this also answers is empty. Okay, and in similar spirit, this first L, this should return the starting point, the starting element of the list, so returns A1. And finally, you want to output the whole list. So that's the question of enumeration. So enumerate list will print all the elements. Okay, any questions? So this is what modeling will do. It defines the data structure, the data format, and it specifies the things that you can do with that format. But these are still easy. The harder operations are the update operations, where you are actually changing, so they are more sensitive operations. So this is first is the just creation of empty list. So what this will do is it will create space, its pointer, and it will initialize. It will initialize to empty. Okay, so this is the first thing you have to do. You have to tell the computer that a list is coming, so you make space for it. Right? So right now it has nothing, but still the computer has done something, which is, even for an empty list, the computer has to allocate something, right? Which is a pointer to this object L. Right? So the pointer is pointing to emptiness, but still the pointer exists. So that is what create empty does. It points to a space which stores nothing. But once this is created, then you can do insertion. So insert an element at a location P, at a pointer P in the list. So insert X at location. So maybe I'll use location or pointer. At location or pointer in L, pointer P in L. So remember that X and P are different types. X is, let's say, integer, while P is a pointer. And this will be important for efficiency. It's not that you have to find the element P and there you have to store X. It's something very different. It's saying that in whatever implementation of list you have done, P is a location, and in that you have to insert X. So in the abstract example, this is what will happen. So if you insert let's say L is equal to 3, 6, 9. list, and P points to six, then when you do insert, let's say you want to insert X at this location P in this list L, then this will give you what? So the new list will become, it will be inserted just before that. So X will come here and 6 and 9. Okay. So this will be the semantics of inserting at location or pointer P. Okay, so what was 6 before will become X now, and everything then on will be shifted forward.
So does this mean insert gives a guarantee that P already exists in the list?
P is a, yeah, I mean, when the pointer or this create empty, what it does is that it has created, so what is the first step, right? You have created the empty list, and let's say pointer P points to the first place. When you say that insert X there, then emptiness will be replaced by X. And here pointer points to 6, so the place just before 6 will be inserted with X. I mean, this is just a syntax. You have to insert X somewhere. So we are saying that you insert in the second location in the list, and obviously this is an insert operation, it's not a delete operation, so nothing will be deleted. So whatever existed before will continue to exist. So it will just be shifted forward. But this is still not implementation, right? We are still talking abstractly, that these are the requirements of your job. And if you insert, you also delete. So that's the next operation. So delete location P in the list L. So this will so in that orange example, if you did delete the same P and L, what will happen? So it will delete 6, right, and you will get 3, 9. So this reduces the length by 1 and insert increases plus 1. And the last one is make empty. So this will force the initialization. Okay, so basically this is the reformatting the list. So list will be deleted and space will not be deleted. At least the first cell will not be deleted. Pointer to that. But the data will be gone. Okay, so this is the modeling part, right, which just seems like a list of demands. So this is your, the ADT should look like this, and the operations should be 6 here and 3 there, or 4 there, okay. So you have to implement these 10 operations. Is that clear? So how do you implement it? So what is the fastest implementation? Because remember that the list is very large in practice. So if the list has n elements, if your implementation is not fast, then it will For simple things, it will be looking at the whole list, right? And you cannot be spending n steps every time. Every time there is a query for an empty room in the hotel, you cannot be searching the whole hotel for the whole year, right? It will be a lot of time wastage in a single query. So you have to store things and implement things so that every query is fast, and assume that there are many queries. So yeah, now we move to the implementation phase, and so as always, we'll start with the bad idea. Otherwise, you will not appreciate the good idea. So the bad idea will be an array-based implementation. So what you do is put L in an array A. Okay, and so whatever be the type, let's say just integers. So array of integers will be used. So A1 will be stored in the A sub 1 will be stored in A0. Right, so you can store the list element AI in the array I minus 1 location. And so I will go from 0 to n minus 1 for n equal to the size of the list. Okay, so this will be an array of size n, so it will go up to n minus 1. So that's the array implementation. So now let us see how good or bad it is. So how fast can you query? So when you want to let me see, so yeah, it's not an operation really here, but so let me spell this out. So finding the ith element in L is the same as outputting AI minus 1. And this takes how much time? Sorry? Oh, so there is already a division. So somebody is saying constant time, somebody is saying n time. What is correct? There is a big gap. Is it constant time, order 1 or order n? So why is it not order n? Yes, so this was an important point then. So it takes order 1 time, not order n. The proof of this is that the reason why the reason why we use array as a first solution is because it has the nice advantage of when I want to look at the ith element. So if I want to read the ith element or edit it, I can directly go to that place. So array is supposed to work like that. Now this actually in practice may not be true, but when you think of an array, you believe this. So array has random access. So it may not be in RAM, but still when you use the word array in computers, what we think of is it's a data structure which is randomly accessible, which means that wherever you want to go, ith location if you want to go. So okay, let us see more about this. So if you want, what this means is that this A is a pointer and moreover A plus I is a pointer. Pointing to what? To the cells. The first one is pointing to A0, wherever this A0 space is, either in RAM or in the hard disk, and A plus I is pointing to, A bracket I respectively. Okay, so this is the advantage in an array. That in an array you have actually a pointer to the first location, and the pointer to all other locations is a simple arithmetic. So in that pointer A, obviously in C you will write A plus I, but the C compiler or the processor, when it executes your C program, it will think of A, it will replace A by an actual location, which will be, say, in hexadecimal or whatever, and it will think of I as some other increment which it will add to A, with the guarantee that A plus I will be exactly the location in that addressing system pointing to A bracket I. Okay, so this is what the compiler guarantees you. You don't have to worry about this. So at the abstract level, this is what an array is providing you. It's providing you pointers to everything simultaneously. You don't have to worry about where what is stored, right? So this allows you in particular with just addressing arithmetic, it allows you to immediately output AI minus 1 in constant time. So this, if you had not known, is an important thing to be aware of. Why we use arrays in many situations, because it provides pointers to everything. Simultaneously you have pointers to n elements. Right? This is the magic of array. This never happens in any other DS. But if you have an array, then simultaneously you know the addresses of all the n things, where n could be a billion, and still you have address of everything. So you can access any location immediately. Now obviously in practice, if you have billion, n equal to billion, then the problem will be for the mechanical engineers who have designed this arm of the hard disk. So the arm has to move a billion times. So those things are the practical mechanical problems, but in the semantics and in the programming level, you have address available. Now how the arm of the hard disk will move, how fast, that we are not discussing in this course anyways. So those will be the optimizations you have to do further in practice. Right, so coming to this blue statement, finding the ith element is constant time. Outputting it is constant time when you do array implement. Question? Yes, so should remember that array locations are So a plus 1 dot dot a plus n minus 1. Okay, in the address notation. So these are not to be thought of as numbers, but as addresses. So bigger your hard disk is, bigger these addresses will be. But just to see whether you remember anything, so if A was of type int in C, what is the type of this A? So A bracket bracket was type int, right? So what is the type of just A? Int star, right? So in C, if you are using C, which I think is same as C++ also, you will have this type of A will be int star. So this actually implies that A is int star. And it's almost if and only if. If A is a pointer, then you can kind of think of an array. Although I should not say that. Let me not put this. But one-sided is fine. Okay, so yeah, we have some time. So let us look at the complexity of now all the operations at once. So is empty on list L of size n, what is the complexity of this? And we have implemented through an array. Array is big A bracket bracket. Yeah, is empty is just yeah, so why is it O of 1? Why doesn't it mean that you go at every place in the array and delete the entry? So when you implement in a C program, you will always keep track of the length of the array, right? Otherwise, I mean, for example, usually as a good programmer, you will not be aware of how big the array will be in advance. So you just create whenever whatever space is required, you create using malloc, right? So dynamically allocate space. So in that case, you always keep a variable which is the length of the array, right? So there is a length variable. So for is empty, you just have to set that to 0. So the array variable is A and the length variable length of A is set to 0. So this is just one operation. So that will be trivial here. So search for X in the list L, which is an array. This will be, yeah, so nobody said that the array is sorted. So in fact, there may not be a meaning of sorting also. If your array was, if your list was, let's say, just random elements, alphabets or things where sorting will not really make sense. In that case, you cannot really use binary search whatever, so you have to look at everything. So that's order n. Okay, let's check successor. So I means we are looking at the address big A plus I, that's the location, and you want to find the successor of this. So this will be, Yeah, now you know this is easy because if you have the address for big A plus I, then you have the address of big A plus I plus 1. So successor predecessors are just order 1, and of course there are these, you don't want to do a segmentation fault, right? If you have not allocated enough space, then I plus 1 or even I minus 1 can do a segmentation fault because it will take you to places in the computer where you are not allowed. So then the program is just forcefully ended by the operating system. So you should be, so check for segmentation fault. So check for end of file in both these cases. Otherwise your program will be killed forcefully. Create empty. This will be, yeah, you just have to create an array of size 0. So this is just declaration. You just say int array A, that's all. So that doesn't count. Now comes a very reasonable demand, which is you want to insert X at location I. So why can't you do that? If you have the address of I, why are you not inserting X just there, constant time? Yeah, very good. So not all of you are asleep. So this is order n because you have to shift. So A plus I is known. But still you will be shifting the later one, so that will be, I think, I to so I means you have written yeah, this is the ith location, so which means I minus 1 actually. It's the, in the array it is the I minus 1, big A I minus 1. So let me correct that. So you will write there, but then you have to shift the rest. So this to n minus 1. You shift this subarray to what? Yeah, I to n. Okay, these are the implementation details. So you, let me write what this means actually. So this means that you want to set E I minus 1 to x. Okay, this is what you want to do. You want to insert element x in the ith location in the list, which means I minus 1th address in the array that you want to set to x, which you can do freely. I mean, you can do in constant time, but then you don't want to lose any, you don't want to lose the original data. So I minus 1 to n minus 1 has to be shifted forward. And it's not clear, I mean, it's actually impossible to do this without looking at everything, right? Because that's how the address arithmetic is. You have a sequence of addresses. If you want to insert an address in the middle, then you have to basically shift it to preserve the address arithmetic. So what do you do with delete? Yeah, delete has exactly same problem. So this is again, so you have to delete and you have to shift back instead of shift forward. And last one is make empty, which is, yeah, make empty is as same as create empty. Okay, so these are the time complexities in array implementation. So the problem is that this insert will be used from day one, right? You create a list and then you will keep inserting and growing the list. So if you call insert n times, the complexity is n square, right? And maybe you will call insert many, many more times than n because you will also delete. So you will insert, delete, so you will be, this complexity is actually very bad. So next time we have to improve on this.